Hi, I'm JD and this is some reflection on COMP348 Assignment 3. So Assignment 3 essentially requires us in the first part to create a specification for a server that serves poems. Kind of an interesting assignment. So to start with, of course, you gotta write a spec document, and I've got one here that more or less does what it needs. It's not a very fancy document, and it gives some examples of how one might generate a request. So in this case, I had several parameters a user could specify. So for example, they could just write poem to return any random poem. They could specify an ID to return a specific one, or actually multiples, and they could return as many, like a certain quantity of poems. They could also specify like a range of lines if they wanted a poem of a certain length. And here's some examples in the documentation. So also the file that contains the poems, I came up with a really simple little format where I have variables or like metadata tagged with these little words that have two @ symbols preceding them. And I did a little transition table because something about the requirements for the assignment implied that we're supposed to define a finite state machine. Not sure if that's necessary, but it seemed kind of silly and not very useful to do this for me, but I did it anyways. All right, so here's my code. Essentially, I just took the old HTTP server from the previous assignment, gutted it so that I can show the this is my test plan here. So I just gutted it and kind of rewrote all the HTTP request handling to handle my special requests for poems. So I will show some of that in a second, but I wanted to do the, if I can find it, poem file. Should be in here. Yeah, so this is what the format looks like. So I've got a few random poems I found on the internet in here, and they're just all split up with these little tags. So that's how my application works. When you initialize this program, it just opens that file that's specified at the command line. So that'll be in main, if I can find that. Yeah, here we go. So where are we? Here's main. So here's some error handling up here. Just if you don't return the right parameters, it will throw an error and print something useful for the user. And if it can't find the file, it prints an error. And once it can find a file, basically just uses some regular expressions to look for the different little tags that I defined. And if it finds them in there, it will read them into a special object that I created, a poem object, and create an array of those. So a poem object is down here. Pretty straightforward stuff. Just has like a string variable for the title, another string for, actually an array of strings for the tags that you can use to search for a certain type of poem, and the text. Yeah, pretty simple. So once I have that array, when I get the request, I can loop through. Where is it? Up here, I've got this loop. Just loops through all the poems, basically looking for a poem that matches the parameters that were passed by the user. So I'll just demonstrate how that works. So I should be able to run it here. So obviously, if you don't specify the parameters, it'll return some nice error messages. So it wants a port, so let's use 8111 and the poem file. Okay, and there we have it. Let's grab this guy and just move this out of the road so I'm not on top of it. So telnet to poem server. So one of the requirements of this assignment is that you display a little welcome message and a list of the poems. So I have 8, obviously, and it gives you some instructions. So you can just return a random one by using a command like poem. And so if I do that again, should return a different poem, although it didn't do it that time. There we go, now it's a different one. Interesting here that these aren't exactly in order, but okay. I guess that's because the way that I'm doing this is that I'm shuffling the array every time you try to access it, so it returns a random item, but that has the side effect that I just noticed of randomizing these. Probably not ideal, but still gets the job done. So we can also return a certain quantity of poems, like say if I wanted 3, I can specify n equals 3, and here's our 3 poems: test poem, atlas, American history. What else can we do with this guy? We can also say that, oh, that's probably not going to help, poem. We can specify a certain ID, like say we want that frog poem. And there we go, we can specify that. We can actually specify multiple poems, so we can do frog and American history, and we get both of those. Not necessarily in order, mind you, because it's randomized. Also, we can specify help. It's always nice. Now we can see what options we have. We can do something like look for a poem with a certain category. Poem tag equals love, and there it returns a love poem. You can also specify multiple tags to say that you want only poems that have all of those tags. And you can specify poems by line numbers. So max lines equals 3, so it won't return a poem that has more than 3 lines if we do that. Or we can do the opposite. You can also group all these things together at the same time. It just uses regular expressions to look for, where do we do that? In the request and call, it should basically set a bunch of variables with all the parameters. If I can find the code for that. Start override. This is the part that prints the help. Yeah, here we go. So this creates all the little variables with the parameters that the user specifies with all the as defined in the protocol, and just runs a function I wrote that returns the right poem that matches all those parameters that I pass. So in a nutshell, kind of a fun little assignment. Got to make some kind of a silly little server that returns poems. I had fun with this one actually. Probably made it a little more complicated than it needed to be. I imagine you could just specify something much simpler that you put in a number or something like that, and it returns the poem that has that number, or maybe you could do it by the name of the poem or something. All right, so next part of this assignment, part 2, involved using remote method invocation. And I didn't really have as much fun with this one. Okay, so first thing you want to know about this is that you've got to start the process, the registry process first. So you want to run this guy, and it seems like in my computer at least it takes a little while before it gets going and things work properly. So pretty simple stuff for the most part. You can take the existing example that calculates pi and just modify the pi function to have it return a prime number, and there's lots of places online you can find instructions on how to calculate prime numbers reasonably efficiently. For some reason I get a bunch of errors sometimes, but it does seem to be running. So just to demonstrate, I can run my client here, and yeah, it returns a number. So what my implementation of this does is it asks for, the client will specify a number. You could do something like 10,000. It'll return the largest prime that is equal to or less than that number. And I also used big int format, so I could specify very, very large numbers, and it'll still work. It does take some time when you start getting to crazy, crazy large numbers. Usually it doesn't have to count down very much before it finds those. So I'll just park that there for a second and see if it ever comes back with the prime. But in the meantime, let's look at the code a little bit for that. So there's a whole bunch of little pieces here. Most of them you don't have to modify very much. The main one that needs modification is the one that does this one I just modified to return some help information if you don't provide the right argument. And this is the bulk of the code here, and it's where I put all my documentation that is required, the test plan and whatnot. But so most of the code, really, the magic is happening right here, where it just starts counting up, determining if you can divide or you can multiply this number and get the number given. It's kind of works through looking for a remainder of 0. If it finds one, obviously it's not a prime number, returns false. I tried to use a technique where you basically fill up this giant array of booleans with a bunch of like true if it's a prime, so 3 would be prime, 2 would be prime, 7 would be prime, everything, the other numbers that are not prime would be false. And then you can just look at the index for the number that you were looking for, and it'll instantly return the status of that without you having to compute every value. So I tried to take a very large, like the largest array possible that has about 2 billion values in it, and tried to make that into a big prime sieve and then use that to look up the numbers, but that was kind of a failure. It took a really long time to generate that on startup. If the server did that once, then the clients could just use that every time, and that would work great as long as all your numbers you're allowing are under the maximum integer value. In my case, however, I was using a big integer to do that. So if we go back, just have another look at the isPrime function, we notice that we're not using an integer, we're using big integer, so it looks a little different than just using an integer. It's a little more complicated to write a function this way, but you have the advantage that you can take extremely large numbers. And if we go back to the example I was running before, it obviously took a couple of minutes, but it eventually found that the largest prime that matches this number, I'm not going to even attempt to pronounce, is this one, and it works. So yeah, I did not really have a lot of fun trying to get this stuff working. The commands are kind of weird. I ended up using, basically modifying the batch files. I'm using a Mac, so I just modified them into little shell scripts so they look like that. They have to run Java with that security policy. And let's see what else we got. Run client.sh. I have another little program that does the compilation, since I had to kind of do that over and over and over again when I was testing. Very handy to have that set up, so this just deletes all your class files, deletes the jar, recreates all that stuff. Pretty handy to have that around. So yeah, in a nutshell, there's assignment 3, and I got a good mark on the assignment, and I had fun making the little server that returns a poem. Not really so much the RMI stuff, but I got it working in the end, and it did what it needed. And I had a big failure with my my idea of creating a prime sieve that has that big array of booleans where you could just look up the state of the prime number, but that was sort of a failure. I will add, though, that in the process of trying to get that working, I did read a lot about how to get RMI working and how it's created, and learned a little bit about the function of all these different little pieces. Most of these are really simple little bits of code that are just taken out of Oracle's examples, but they get the job done and work. So anyways, thanks for watching, and I hope this has been helpful.